Assalamu alaikum. Myself, Said Sifat Al Shahriar, and I am with my groupmate Jinat Firdaus. Today, we are presenting our LAB-1 exercises of Computer Organization and Architectural course. So, welcome to this video series on Assembly Language Programming. In these videos, we will explore the fundamentals of assembly language, its relationship with computer hardware, and how to write code at a low level. We will dive into various code snippets, learning about variables, register, arithmetic operations, and more. Okay, so let's start the part B. Okay. So here is our part B, you can see. So here code is a simple assembly language program that performs addition and subtractions on 32-bit unsigned integers and stores the result in a variables. Okay, so the title directive sets the title of the program. Comments provide an overview of the program and mention the authors and project details. Okay, the .data sections declares the data segment where variables are defined. Val1, Val2, and Val3 are initialized with 32-bit hexadecimal values. Final val is an uninitialized dword, which is 32-bit variable that will hold the result of the calculations. So the .code sections declares the code segment where the program's instructions are written. Main is the entry point of the program. The move, add, and sub instructions perform arithmetic operations on the EAX register using the value stored in val1, val2, and val3 as well. The result is stored in the final val variable called dumpRex. Invokes the dumpRex procedure to display the contents of the register. Okay, so now let's exit the terminates programs. Okay, so now let's go and see the windows. Okay, so the first monitors variable values during program executions. You can see the output here. Okay. Okay, so after exit the terminates, now let's rebuild without debug first. Here you can see the output, which is without debugging. Now let's again rebuild this with debugging. Here you go, the output here after the debugging. Okay, so now let's see the windows now. Okay, so first monitors variable values during program executions. So let's start with autos window. Okay, so here we are going with autos window. Okay, so here you can see. Okay, so here is our autos window output, displays the local variables. So here is our autos windows output, which displays the local variables and their values while stepping through the code. Okay, so the next is the memory window. Okay, so here is the memory window. So here inspects program memory, including code segment, data segment, and stack as well. You can check it here. Okay, so now the next one is about register window. Okay, so here is the register, and here let's watch the register. Okay, okay, so Here shows current values of CPU registers during the program execution. Okay, so now let's go with the last one. Here we have the disassembly window. So here displays the assembly instructions and corresponding machines code. Okay, so this is all about part B. So I will hand it over next part to my group mate, Jinat Firdaus. She will discuss about the part C of our lab 1.
Hello, thanks, Syed Sifat Al-Shahriar. I'm Zinat Firdaus. Okay, I'm going to do the lab 1 part C. Okay, let's just start it. Here the very okay. Here the title and comment provides a brief overview of the program and the author and the project detail, as me and my groupmate did all of this together. Okay. So variables are declared in the .data section, including 16-bit unsigned integers like value 1, value 2, value 3, and 8-bit unsigned integers value 1, value 2, value 3, and final value. Okay. The dot code section contains the program instructions. The first part calculates the sum of 16-bit unsigned integers, the value 1, value 2, and value 3, and the stores in the final value here. Okay, so second part calculates. Okay, this is the second part. Second part calculates the sum of 8-bit unsigned integer value 1, value 2, value 3, and the final value for the result. Okay, and this call them range here and here. This one produce procedure to display the content of the register, and exit terminates the program. So let's try to run it without debugging. So here is the output of this program. So let's watch the windows for like watch window. So before this, we need to debug it. Okay, here we can see all the windows. So this one is the memory window here, and the register window will be here, this one. Okay, so for the watch window is here. It monitors the variable during program execution. The AUTOS window, okay, for the AUTOS window. Okay, so for the AUTOS window, displays local variables and their values while stepping through the code. And then the memory window, you can see here. So the memory window inspect program memory, including code segment, data segment, and the stacks. Okay, for the registers, you can see here. It shows current value of CPU register during a program. Okay, for the disassembly. For the assembly window, it displays the assembly instructions and the corresponding machine coding. So all are here. Thank you. That's from me. And please, you can conclude the our program.
Okay, so thanks, Jinat. So these videos provide an introduction to assembly language programming. We explored code snippets that demonstrated arithmetic operations on 32-bit unsigned integers and introducing both 8 and 16-bit operations. By studying these examples, we gain insights into variables, registers, and program execution flow. So, this knowledge forms a foundation for further explorations of assembly language, programming, and computer architecture. So thank you everyone. That's all for these explanations, and thank you for watching our video.
Thank you. Bye bye.